रहस्य की बात है।
Welcome to our final segment on the Milky Way. In this segment, we'll go over our current understanding about the structure and size of the Milky Way as a whole and our place in it. We'll examine the galactic center with its supermassive black hole. We'll go a little deeper into the nature of a black hole. We'll explore the galactic disk with its spiral arms, and we'll cover the latest information on the galactic halo. And, as usual, we'll discuss how we came to know these things from our viewpoint deep inside the galaxy itself. On January 1st, 1990, from its orbit around the Earth, the Goddard Space Flight Center's Cosmic Background Explorer created this edge-on view of our Milky Way galaxy in infrared light. Here's a newer inside image of our galaxy. In fact, it's the most detailed spacecraft that recorded the position and brightness of 1.7 billion stars, as well as the parallax, proper motion, and color of more than 1.3 billion stars. The map shows the density of stars in each portion of the sky. The galaxy has a center with a central bulge, a disk of rotating stars and dust, and a halo without dust clouds and peppered with globular star clusters. The disk is at least 100,000 light years in diameter, and the halo is much larger than that. We'll go into each of these galaxy components, starting with the galactic center. We'll cover how images like these are created from inside the galaxy and how impossible it is to get an image from outside the galaxy later on in this segment. The world's great Spitzer Space Telescope and the Chandra X-ray Observatory have collaborated to produce this unprecedented look at the central region of our galaxy. Hubble documented vast arcs of gas heated by stellar winds from very large stars. Spitzer's infrared picked up the pervasive heat signals of all these stars. And Chandra detected X-ray sources from ultra-dense neutron stars and small black holes. Together, they produced this spectacular image. The central object in the Milky Way is known as Sagittarius A star, or SAG-A star for short. It is surrounded by so many stars and gas and dust that it is almost impossible to see. Teams of astronomers and astrophysicists have been working on understanding Sagittarius A star for over 25 years. The UCLA Galactic Center Group, along with the Keck Observatory on top of the Mauna Kea volcano in Hawaii, and the European Southern Observatory and its array of very large telescopes in Chile, and the Max Planck Institute for Extraterrestrial Physics in Germany, and many others have made dramatic progress in advancing our understanding of this critically important part of our galaxy. After decades of careful observations, the speeds and orbits of around 45 stars around SAG-A star have been calculated. This enabled measuring the precise location of the point they are all orbiting around. The measured orbits also identified the gravitational pull from this point, which in turn gave us its mass at 4 million times the mass of our Sun. But when we look at this point, we don't see anything. This was strong evidence that SAG-A star was a black hole, because stars are known to be unstable at much smaller masses. The star S2 is of particular interest because it passes closer to SAG-A star than any other. It's a single main sequence star with 10 to 15 times the mass of our Sun. Observations of the star showed that its orbit took it to within 20 light hours of Sagittarius A star in 2002 without bumping into anything. That puts Sag star's 4 million sun mass into a very small place. For many astrophysicists, this constituted proof that it was indeed a supermassive black hole. But others pointed out that an extremely dense, dim star cluster could produce these results. But if Sag star were a cluster, S2's orbit would wobble. It did not wobble. This was the final proof point. 500 years after Copernicus put the sun at the center of our solar system, this team identified Sagittarius A star as a supermassive black hole at the center of our galaxy. But we weren't done with S2. Its orbital period is 16 years. Following the 2002 passing, a major effort was mounted to upgrade ESO's Very Large Telescope Array to enable the precision needed to reveal the true geometry of space and time near this object and test Einstein's theory of general relativity. These new instruments followed S2 very closely. At the start of 2018, it was accelerating towards Sag A star, reaching relativistic speeds. On May 19th, it reached the closest approach, pericenter. At that point, it was traveling at 7,650 kilometers per second, or 4,753 miles per second. That's almost 3% of the speed of light. Its distance from the black hole was just 18 billion kilometers, or 11 billion miles. That's only 120 times our distance from the sun. The separation on the sky between the 2 points was just 15 milliarc seconds. It was also reddening in color as the black hole's gravitational field stretched its light to longer wavelengths. The color change in this illustration is exaggerated for effect. The actual reddening is quite small and would not be visible to the naked eye. S2's velocity changes close to the black hole were in excellent agreement with the predictions of general relativity. In addition, the change in the light wavelength agreed precisely with what Einstein's theory predicted. But understanding what is happening this far away is always prone to errors. I remember when we thought there was a gas cloud, G2, that would be entering the black hole in 2014. This never materialized. In our current case, some astronomers point out that massive non-luminous objects, such as stellar mass black holes, might be present and could affect the orbital dynamics of S2. More research is needed to rule out this possibility. Here's a full dome illustration that shows how Sag A star might look to viewers on a planet orbiting S2 as it orbits the black hole. We'll cover black holes and why our supermassive black hole might look like this. But first, we'll cover how the ESO Very Large Telescope actually measured the minute distances associated with S2 and Sag A star, 26,000 light years away. The Hubble Space Telescope can resolve angles on the sky as small as 50 milliarc seconds. The angular distance between S2 and Sag A star at pericenter was just 15 milliarc seconds. That's 42 billionths of 1 degree, and 3 times smaller than Hubble can resolve. To follow S2 as closely as they did, astronomers had to use a stellar interferometer. These kinds of telescopes can resolve images 30 to 40 times smaller than optical telescopes. This makes them extremely important tools for studying the galactic center, as well as exoplanets. They can even resolve sunspots on nearby stars. So to understand how we know how close S2 got to Sag A star, we need to understand how these stellar interferometer telescopes work.
not be aroused if a woman is touching your head. A woman is touching your head, you will not be aroused.
How would you know? I still feel like I go on set and there are 3 women and 70 men. But I'm so used to it that the more women I see, I'm like, what is this feeling of my traps coming down? You know? It's a new feeling. It's a good feeling. It's about the willingness for even men to change and to understand what is happening and to have a conversation.
They were like, but the title's basically a little more lopsided for the girl. And I'm like, I didn't realize that. Like, what does it mean, the title? Right? Like, you read the film for the script it is.
There are women who sort of stick it out and they will make it to these figures that we are speaking about. So, merely to even if it is a 1% change, I feel happy.
169 line items in the budget that we put down, ATL, BTL. Do you know how many are considered jobs, relevant jobs for women? Take a guess on.
I can't.
9.
No way. Welcome everyone to the Ovomanya Roundtable. Ovomanya is an annual report on women in Indian entertainment. This is the 4th year that we're doing the report. This year, we looked at 169 titles. This report is presented by Amazon Prime Video. The research is done by Omax Media, and it's produced by Film Companion Studios. So you have 169 titles, including theatrical, streaming films, and series. And the report looks at where women stand in front of camera, behind camera. I'm just going to tell you some key findings. The report looks at a lot more, but this is just like the tip of the iceberg. So female HODs in key departments such as direction, editing, cinematography, writing, and production design is only 15%. If you split this up into streaming and theatrical is only at 6%. It's 22% in streaming films and 20% in series. So everything on streaming is ahead of theatrical. Sadly, in the South, the number was already critically low, but it's dropped from 5% to 4%. And here's what really gets me. This report also looks at trailer talk. How much do women talk in trailers? Trailers for movies, trailers for streaming movies, trailers for series. They only talk 30% of the time. The rest of the time, only the men are talking. Okay, and the thing is, these numbers are good in the sense that it's better from when we had first started 4 years ago, but the change is so small and it's so slow that it's a little heartbreaking. So I want to just begin by asking all of you that, are these numbers a reflection of your lived reality? Is this better or worse than what you had imagined? Anyone?
Well, I think when you're making a film, you are in a bubble, right? You don't think of the whole industry. You just think of your unit, your film. And I guess I'm a little surprised because when I'm making a movie, I mean, last movie I had Deepika, I had Ananya, my co-writer, Aisha, who's been with me for every film. So
Most
I feel
of the
like
HODs also. Huh? Most of the HODs also.
Yeah, so I feel like I've always felt surrounded with enough women. So I haven't felt the lack, but now when I hear the numbers, you obviously feel shocked. Yeah. And obviously there is a need for a conversation. So
yeah, I mean, I look at some of the films that we've just had on our service. We have an example of a delightful show we did called Dil Dosti Dilemma. The entire HOD crew was female. So I know that that is an exception and it's something to aspire to. But I think when I look around this room, this bubble does have facts that negate that statistic. But it also goes to show how much that needs to change then. Because, you know, we're obviously the minority when we look at our crews on the films and the projects here. And it absolutely has to change. It has to change.
Parvati, it's gone for the South from 5% to 4%.
Yeah.
What?
I'm just trying to see. This is the first time I feel like I'm good in intuitive math. Like what I'm feeling and like I'm living is what is reflected in the data. If it was different, I was looking forward to be surprised, pleasantly surprised. But this is shocking. But I also feel like it ebbs and flows. And before a big change is to happen, there is going to be resistance. And I genuinely feel when a lot of aspects of our filmmaking community, I mean, taking filmmaking community as a cross-section of the society, that there are a lot of doors that are closing because a lot of exploitation is being put to end. And so there's a lot of like, let's grab what we can, let's close that, let's try to maintain status quo as much as possible. So I can feel the tippy toes scrambling quite a bit back home. But the thing is that this change is coming. It's like winter's coming. But it's more like, it's less